Good afternoon, everyone. Thank you for joining Panel 1, Session 3, How Agile Manufacturing Helps Achieve Sustainability. My name is John Dyke. I'm the Chief Executive Officer of SESME, the Smart Manufacturing Institute, spelled out that is the Clean Energy Smart Manufacturing Innovation Institute, a duly funded Manufacturing USA Institute focused on smart manufacturing, clearly, and the opportunity to the strategic value of using information to drive energy productivity. And I was thinking through some of the panelists here about the idea that agile manufacturing and sustainability isn't just about the direct initiatives focused on those things, it's also about the broader impact of improving quality, of reducing losses, of understanding how we can create really effective, efficient energy that all have to and I think it's exciting to kind of hear the great presentation. Let's keep that in first, and then we'll get started. First of all, thank you to all sponsors for making this event possible, especially due to you. Due to the first time it's possible, and we have to find a good and give it a site to learn more about it. We have an exciting we work with all remaining unanswered questions and send them to the speakers to respond. If you'd like to connect with other attendees, please take advantage of the attendee link at the top of the left-hand corner of your page. Any attendee who has created a profile can be found there. In this column, you will find attendee resources as well. The resources contain the conference proceedings, attendee list, and an evaluation survey to complete at the end of the conference. Anyone who fills it out and includes their name and testimonial will get a discount to attend the 2023 summer study. In the program participants link, you'll find information about all of the presenters, including bios and copies of their presentations. Last, please plan to join us at the end of the day, which will be shortly after this session, for post-panel debriefs to learn about other discussions that you may have missed. Remember, all sessions will be recorded and available on demand after the conference. Just as a final bit of advice as we get started, make sure you post your questions in the chat box at the right-hand side of the screen. All three presenters will speak, as I mentioned, for roughly 20 minutes, and then we'll have a total of approximately 15 minutes to address your questions. So with that out of the way, let's get started with our speakers. Our first speaker is Peter Bassett. Peter is the President of Energy Performance Services, EPS. He's specialized in industrial energy management over the last 35 years. He works with organizations in North America related to strategic energy management, SEM, energy management information systems, EMIS, and energy management systems such as ISO 5001 and 5001 Ready. With that, Peter, the floor is yours.
Thanks, John. I'll just get my, well, let me just see here. Where do these slides go now? I'll do it this way. I'll give this a shot here. Can I just ask confirmation if the slides are visible? And I will need somebody audio to tell me that, or let's see here. Go back to the chat. Can somebody chat to say, can you see that? Were you able to see those slides? No, you can't see the slides. Okay, so I got an issue. Let me try again. Window, there we go. I think it'll work this time. Okay. Should be good there, I assume. And I apologize, but I'll just take a second just to confirm. I saw Julie told me no before. Can I ask if I get a confirmation? Were you able to see the slides now? I know I'm back off screen, but were you able to see them? Okay, I think I'll go into it and I'll give it a whirl. Okay, so good afternoon, everybody. I'm presenting a paper on our experience within Michigan, the Detroit Energy DTE Strategic Energy Management Program, work with Stellantis, major vehicle manufacturing company. Authors of the paper are myself, Kevin Dunbar, who's Corporate Energy Group Supervisor, and John Nickel, who's Program Director of Energy Efficiency Services for Leidos. What I'm going to go over today is really four sections here. The first is high-level picture of the roles and responsibilities of various parties in the Strategic Energy Management Program. Some background on where Stellantis is coming from as an industrial organization that is focused on energy management, was already focused very heavily on energy management before they joined the SCM program. I'll give a brief overview of the DTE SCM program and how the process works. And then finally, really get at the core issue of how we pivoted with the onset of COVID to combine people with digital information on substantial energy using systems to generate actions that drove energy savings despite the challenges of the COVID period. So very high level, who's who. So the Stellantis Corporate Energy Group, which participates actively in the SCM program, they lead energy management within Stellantis in North America for 26 plants. And these are very large automotive, truck, vehicle manufacturing plants. Within each of the plants, within the facilities group, which is part of the manufacturing organization, there is a dedicated energy lead. And that energy lead really acts as a key working level partner for the SCM team. So the SCM team is composed of the energy lead, the corporate energy group, and the SCM implementer, who concentrate on working at a specific site to drive operational energy savings only in the SCM program. So we're strictly focused on operational, not capital. The SCM implementer, in this case EPS, provides coaching and support resources to effectively drive the process. Leidos is program manager for the SCM contract with DTE. And DTE is, of course, the program administrator. So this is the fundamental structure of the SCM program and the various roles and responsibilities. Talking about Stellantis in energy management and their background, they have a very substantial scope, 26 manufacturing facilities, US, Canada, Mexico, assembly, stamping, transmission, engine, casting, and machining plants. The corporate energy group is located inside of manufacturing operations in the facilities group. So it isn't a separate corporate type initiative. It's literally embedded within manufacturing, the manufacturing organization. The corporate energy group is 5 key individuals who then support the individual plants. Each site has an energy champion, but the corporate energy group divides up plants and supports individual plants. The organization has an enterprise ISO 50001 cert. So all of the facilities are certified to ISO 50001. They're audited, and they maintain that certification. And I think a key issue is the corporate energy group is aligned with senior management, and it has upper management support. And in particular, in 2018, they laid out a specific strategy, an energy strategy, was approved by senior management. And there are 4 main principles: financial, technical, communication, and knowledge. So going through how Stellantis is organized and how the SEM program then brought alignment. Their first principle, financial, is driving down energy cost and optimizing the receipt of incentives. And they've got very aggressive KPIs around this. They really call it transformation cost, the cost of transforming a vehicle from its raw material state into a finished vehicle. These are numbers that are watched very closely, and there's exact targets by plant for the energy transformation cost to bring that down. So first of all, at a very primary level, the SEM alignment, I think, brought forward 2 pieces, one of which proved critical in COVID, which is that we were focused on operational savings only. So this did not require capital expenditure. There's savings that can be achieved by the plants by using assets that are already there, namely people, information, technology, combining human intelligence with data and information systems to drive better use of energy in the operating arena. And of course, we can provide incentives for that, and it reduces their utility costs. So direct alignment with the financial principle. The second is that Stellantis really has a very strong technical focus to concentrate on the plants finding energy savings, doing energy treasure hunts, cross-fertilizing ideas, sharing best practices, and maintaining their status with the ISO 50001 system. And I think what the ICM program brought into play was their historic concentration was primarily on capital work, and we brought in the focus on operating systems and getting to opportunity within operating systems, and particularly with SEM, the ability to be on site to treasure hunt was eliminated. In fact, for meaningful periods, plants were closed, and we were working with them to remote diagnose the idling loads of these plants, which were quite substantial, and to start to attack the idle load. And then the fact that they are mature ISO 50001 certified entity, the language of energy management beyond just straight, say, project focus around things like operational control, management reviews, energy planning. Really, we were able to converse in a detailed way in some more sophisticated language to get at the kinds of opportunities that we're going after. They've also listed communication as a key principle. So the champions are active, communicating in the plants. Plant managers play a role in the Stellantis energy KPIs, are met with each quarter to review progress. Division managers, corporate are all involved in communicating the importance of energy management down the line, and there's KPIs and targets to back it. On the SEM side, what we brought into play was really an intensive communication process. Firstly, weekly 1-hour meetings with the energy champion and the corporate energy group. And I would say that we maintain that right through COVID. So people were showing up even from home, dialing into plants, connecting us on the screens, and we kept functioning in energy management. So regular meeting communications, we hold semi-annual management reviews with plant managers. Plant managers are critical to resource allocation and also roll out employee engagement plans and execute on them. So again, alignment. And then finally, as many folks know, in SEM, to support Stellantis' focus on knowledge, we have workshops, work with the champions on a weekly basis. The virtual hunting, treasure hunting was new for them, and they've articulated, they learned a lot, and we've helped to evolve the information, the energy management information systems. So quickly to go through the basic SEM program, I think it's fairly known to most people. It's a comprehensive approach whereby organizations systematically manage energy to continuously improve energy performance. We focus on not just technical work, but changing business practice, establishing organization cultures, to be able to verify also the results from these activities. As far as the money goes, the incentives are broken into milestone grants that support the organization to get out of the blocks early, create an action plan, and there's a $5,000 action plan incentive, milestone incentive, when initial ideas are brought forward from the energy team. Secondly, $15,000 when that initial plan is fully implemented. But the much larger money is in the cents per kWh or therm for operational energy savings. In Michigan, this almost doubles the value of the savings. And so this is really the much bigger carrot. And this is where we go from tens of thousands to hundreds of thousands of dollars of financial benefit. And then there's a third element to this program where for every kilowatt hour or therm saved, there's additional money put into a bank, which money can then be used to double up capital incentives to basically enhance the incentive value for doing capital work. So through SCM, we're trying to also create activity in the custom program. I won't go through the details of the workshops or the site level activities, except to say that the workshops are designed to help the organization build competency within their energy team, to establish an SCM program, to treasure hunt, to design employee engagement program, and also to do management reviews. And then there's site-specific activities that concentrate on a custom basis, site by site. And I would mention that with our method of SCM delivery, it's an individual approach as opposed to cohort approach. So we're working one-on-one with each of the sites. So really now to get to the heart of this, I first would like to just introduce the idea of operational control. I'm even going backwards to the 50001-2011 standard because the language there is just very clear. The idea here is operational control. And this is at the heart of how I think we pivoted with Stellantis during the COVID period. The idea of bringing into focus your significant energy uses So that could be a compressed air system, a chiller system, the HVAC systems, paint ovens, a wide array of equipment, establishing and setting criteria for effective operation and maintenance of those uses, where the lack of a criteria could lead to a significant deviation from effective energy performance. Then communicating those criteria and then operating and maintaining, getting people to take those actions. And then finally, monitoring and measuring. So having some kind of performance feedback on how well those systems were operated relative to the criteria. So I bring that up just to say, this is behind really how we've been going at the operational energy savings. Stellantis understood this language. They're certified to ISO 50001, and we really use this as a key concept to drive into their systems. So now taking the organization on the left that we introduced earlier, looking at the energy uses in the plants, and speaking of which, we're working with 5 Stellantis plants. So several different plants and of both stamping and assembly plants. So large, significant energy uses for electricity, compressed air, chilled water systems, lighting, systems that use both electricity and gas, HVAC, process energy, boilers, steam systems, hot water systems, and so on. These were, are some of the large energy using systems that we wanted to attack ordinarily through SCM, and we were going down the road, and then COVID hit. Literally, the plants went into an idle mode. People were out of the plants. It was down to security guards and some key people. But the idle loads on these plants were quite large. And so we began to remote diagnose them. And the way we got at this was Stellantis has a substantial array of information systems. At the top is a billing dashboard. So their utility bills are handled by a third-party provider, and there's certain dashboard for that. They get from DTE direct view line of sight on the main meters for the facility. Baywatch is a system that sits on top of the compressed air system in the powerhouse. Automatic line stop, quite interesting. Custom program developed by Stellantis to start to build in automatic controls for shutting things off if certain conditions occur within production. They have EMS, energy management system. Leidos is a prevailing system that controls a lot of the facilities, primarily HVAC, and to some degree auxiliary systems. And then an advanced module within the Leidos EMS called RT-EMS, where targets and standards are starting to be set and thresholds for managing those systems to target values. TechWorks sits over the chilled water system. FIS, the factory information system, is there for their production, and GE Daintree. So they had all this array of information technology. It was being used primarily to operate the systems. What we brought into play in SCM, what we proposed at the beginning of COVID, and Stellantis said they were all in. We talked to DTE about being able to go after these kinds of savings. DTE supported it. And so we actually brought a fairly simple Excel table into play to define where these systems should be in a zero state condition. So the modes would be zero state, where the target should be, who's responsible to get it there, And we began to attack these systems one by one. So compressed air, for example, is one of those systems. It's run actually outsourced to DTE. So we had to get in cooperation with the people working in that powerhouse and look at the pressures, look at the flows, the number of compressors being operated, and start knocking things down. And so the team worked diligently on establishing those controls over those subsystems, really drove the idle load down. Stellantis took this and then wheeled it out to their array of plants in North America and achieved a record energy savings year. But we also discussed that we would use COVID as an opportunity to flex that muscle and then expand these modes as things moved on. So if we have a 24-hour down weekend or a 2-day weekend, we start setting targets, build those threshold values, educate people on those targets, have clear accountability, and start to really manage and squeeze out the waste during non-production periods. And as you can imagine, as an international vehicle manufacturer, there's lots of competition out there. They cannot afford to have a lot of excess energy, excess cost, and this is in the many millions of dollars. And so the heart of this project, I would say, which aligns, I think, with this particular theme in this ACEEE conference, is putting together the ingenuity of people, digital information systems, and accountability to drive energy waste out of manufacturing plants in North America. The systems were there, but they weren't being used for that purpose. And so this was really the heart of our initiative. Now, as we've moved, out of a diminishing COVID, there's a chip shortage that's hitting these plants, so they have 2-week down periods. There's other things. There's regular schedule breaks, it's now shifted into a excellent plant shutdown initiative, where we're going to expand this to go after 4-hour windows, 8-hour windows, 12-hour windows, to really drive out energy waste that's not required and not adding value to the finished product. So in summary, Stellantis uses their energy strategy to manage consumption and change. In Kevin's words, Kevin Dunbar from Stellantis, the participation in the SEM program allowed Stellantis to drive improvement of all aspects of the energy strategy and greatly contributed to the success of the overall program. So in conclusion, we put together people, digital information, combined with large energy using systems, and drove improvements. They transferred that across their fleet of plants, and were able to capitalize on it. It sounds simple, but it required real adaptation and innovation on the fly. But I do think that there's enormous scope moving forward to combine people, digital information, and energy management to drive substantial energy savings. So thank you very much for the opportunity to present this today.
Wow, Peter, thanks for a very compelling presentation. I've worked with Chrysler/FCA, now Stellantis. We're continuing to work with Stellantis, and I can say firsthand that even though they're a very complex organization to work with, that I'm thrilled to hear from this vantage point about their focus on these important issues. And sounds like you've had a great experience working with them there. There's a few questions listed, which we'll get to at the end of the session after the other two speakers. But let's go ahead and I'd like to introduce you to Christopher Dyson. Christopher is a principal consultant with DNV, over 20 years of experience managing market studies, focusing on the adoption of energy efficient and demand response capable technologies. In 2021, he completed a study for the California Public Utilities Commission, which focused on the energy efficiency and demand response opportunities for 6 key California industrial and agricultural subsectors. From 2010 to the present, Mr. Dyson also managed a half dozen studies of the commercial and industrial markets for energy efficiency products in Massachusetts. These have included studies focusing on the C&I lighting, HVAC, energy management system, retro commissioning, and combined heat and power markets. So with that, Christopher, the floor is yours.
Share my screen. By the way, I have a thunder shower going out outside my office window. So if you see flashes or loud booming sounds, that's what's going on. So hopefully everyone can see my presentation. I'll just put it in presentation mode. So this is a study that was sponsored by the California Public Utilities Commission, and a key partner of ours was Guidehouse. And most of the research was conducted in 2020, but the results were published in 2021. So just a brief agenda. So I'm going to start with a brief touch on backgrounds and objectives, then get into how we selected the industries, how we estimated market saturation, also show results, talk about how we estimated energy savings, also show results, and then talk about barriers, and finally key findings and recommendations. So as John mentioned, this study was sponsored by the CPC. There are a lot of research objectives. I'm not going to go through all of them here. The most important one was that this study actually fed into a larger study called the California Potential and Goals Study that was managed by Guidehouse. So all the data that we produced, or most of the data we produced, fed into this larger technical potential study. So the 3 industries that we selected were food production, chemical manufacturing, and electronics manufacturing. The study also focused on some agricultural subsectors, but because of the nature of this conference, I'm only going to be talking about the industries. So first we had to select the industries, and the way that we did this was energy consumption was the primary criterion. So the California Energy Commission does these projections from 2020 to 2030 about which California industries consume the most energy. And so this table here shows the top 5, and you can see that we picked 3 out of the top 5 to focus on food services, chemical manufacturing, and electronics and semiconductor manufacturing. The biggest one was petroleum, but we decided not to focus on them, and the main reason was due to COVID. So we all remember people were not driving, people were not flying, and in general, the petroleum industry in California was in crisis. And we figured that even if we got people on the phone, that they probably energy efficiency was probably pretty low on their priority list, and we weren't sure if the answers we got from them in the interviews would be representative of what they would say in a typical year. So for that reason, we decided not to cover petroleum. So once we had selected the industries, we had to select which energy efficiency technologies to focus on. To do that, we started with a lit review, a database review, and then we did interviews with 40 what we call subsector experts. And these are people that work for the utilities, that worked in academics, that worked for the National Energy Labs. They were the program implementation contractors. They included people like myself who are evaluators. And some of these names we got through lit review. If people authored a white paper, we try to reach them. And other referrals came from the initial interviewees. So you talk to Joe, and he says, Chris, you really need to talk to Bob. So those are how we got the pool of the panel of experts. And so we asked each one of these experts to identify the 3 most promising technologies in each of these 3 industrial subsectors. And this criteria included, how much did the end use account in terms of energy consumption, of that subsector's energy use. So for example, in electronics manufacturing, actually HVAC consumes a lot of energy because of all the clean rooms to make the semiconductors. So that was an important factor. Other factors are, did the measures have large untapped energy savings potential? Did multiple experts recommend the measures? Was it frequently mentioned in the subsector literature? And also a very important resource, which a lot of you are aware of, is the DOE has the Industrial Assessment Center IAC database. And these are database of industrial audits. This is a valuable source for determining which measures to prioritize. So after we had selected the measures, our next research objective was to come up with estimates of market saturation in these California industries. And we kind of approached this from two different directions. So first, we completed in-depth interviews with almost 50 equipment vendors, and we asked them, how prevalent are the technologies that they sell in these three California industries. And then we also we also interviewed about 30 California industrial end users. And because the sample was relatively small, by design, we did oversample the larger facilities. We wanted to get kind of more bang for our buck. And then we asked them whether they install the energy efficient technologies in their facilities. And our hope was that, between the equipment vendor perspectives and the end user perspectives, we'd come up with roughly similar estimates of market saturation for California. So this table shows what we found, and it's a lot of information here, so I'll walk you through the table. So the first column shows the subsector. The second column shows the 9 energy efficiency measures that we came up with. The third column shows the market shares or market saturation that was estimated by the end users. The next column shows the estimates from the vendors. And then the final column is just an average of the two percentages. And what you'll see here is that, I guess all the stars aligned, and there was actually, for most of these measures, the estimated market saturation levels were similar from what the end users were saying and what the vendors were saying. So this gave us some kind of assurance that we're on target. The one exception was the refrigeration system optimization. But for all the other measures where we had two estimates, the two estimates were fairly close together. And so that was reassuring that we were on the right track. So the next research objective is that we had to calculate estimate energy savings for these technologies and these systems. And our primary source for this were interviews with equipment vendors. But because, as we all know, equipment vendors can sometimes have a positive bias, with saving estimates, we backed it up with a lit review, and we also consulted previous PG studies that provided additional energy savings estimates. And one thing in terms of kind of lessons learned in terms of methods is it's very important to be precise when you're asking about energy savings. Is energy savings of what? So if someone says this widget will save 20%, is that 20% of the boiler? Is that 20% of the facility? So getting that denominator right was very important. It's also important when you're trying to find out energy savings estimates for retro commissioning and advanced automation. You need to find out exactly what equipment are they talking about, and how much does that equipment account for the total energy consumption in the facility. So here's the findings we had from the energy savings. Once again, the first column is the subsector. The second column are the measures. The third column is the actual level of energy savings. This is an average of all the vendor responses. And then the final column shows the end use or equipment type that was impacted. So whether it's the chiller plant or the refrigeration system or the pumps or motors, where is the energy being saved essentially? So our final research objective was to identify barriers to energy efficiency adoption. And here we had a kind of embarrassment of riches in terms of sources. We asked various questions of the experts, the vendors, the end users, and also we looked for barriers in the lit review. And so all the barriers here were cited by multiple sources. So food production, there was a lot of barriers. I'm not going to go through all of them. I'm just going to highlight a few of them. So seasonal or episodic production schedules for food production. So when you have your crop of Brussels sprouts or whatever, they're coming at a certain time, and so that can complicate the economics of energy efficient investments. And also, California has a lot of smaller food production, things like small wineries or microbreweries. And for these kind of companies, first cost barriers are a major consideration. And then also, we found out through our interviews that a lot of these food production facilities have refrigeration systems that have kind of been cobbled together over many years. And so in order to extract energy savings from those systems, you really need to have a customized solution. And so that's another challenge for that subsector. Moving to the other industries, for chemical manufacturing, competition for capital, especially from process-related projects, is a big barrier. Also, low energy costs. So low energy costs impact the payback period and the return on investment. Another big barrier is concern over lost production due to downtime required to install and commission more energy efficient systems. There's concern about possible negative impacts of technology on the product quality or yield. And then for electronics manufacturing, key barriers included concerns about disrupting production, concerns about initial costs of energy efficiency, and then energy savings not being a priority. So the CPC was very interested in how much competition was energy efficiency facing from other energy-related projects. So these might include renewables, include demand response. So we asked the end users, we used a 5-point importance scale, where 5 meant very important and 1 meant not important at all. And we essentially asked them, for these 4 different types of energy-related projects, which ones are more important for your company? So the bar chart, the blue bars are energy efficiency, the orange bars are renewables, the gray bars are energy management systems, and then the yellow bars are demand response. And so what you can see here is that for electronics manufacturing and also for food production, energy efficiency and renewables are practically neck and neck in terms of importance. So that indicates that the CPC's concern about this issue is a valid one. However, and I'll show you in the next slide, we did ask these industries whether they had solar installations at their facilities. And the market penetration of solar in these 3 industries was very low. So it was only 10% for electronics manufacturing, only 14% for chemical manufacturing. The highest was actually in food production, which is at 36%. And the information we got from the interviews is that some food producers get branding advantages from indicating that their power comes from solar energy. So that's why that percentage is a little bit higher. So finally, the key findings and recommendations from the study. So one finding is that these selected measures offer the promise of significant energy savings. So of the 9 measures that we looked at, 2 of the measures had average energy savings over 30%, and 4 others had average energy savings over 20%. So that's quite large. Another key finding is that there are opportunities for more customer education. So only 20% of the chemical manufacturing end users were familiar with advanced automation and optimization measures. Only 40% of electronic manufacturing end users were familiar with chiller plant optimization measures. And this is important because lack of customer knowledge of energy efficiency benefits leads to energy efficiency projects being undervalued when competition for capital is already stiff. So if you don't know the benefits of the energy efficiency project, you're not going to do a good job of selling it to management. However, and I'm sure many people on this call are aware of this, is that when you're dealing with industrial customers, it's very important to be able to kind of talk their talk. So it requires people who work for energy efficiency programs or implementation contractors to know how a chemical manufacturing plant operates. And sometimes it's hard to find people that have that level of specialized knowledge. And my final slide shows that there are sizable opportunities for energy efficiency improvements in these industrial subsectors. So for 5 of the 9 measures that we looked at, the market saturation levels were below 40%. And only 1 measure of the 9 we looked at had market saturation levels above 50%. So there's a lot of untapped potential in these 3 industries for those types of technologies. But finally, significant market barriers remain. These include low industrial energy rates, competition for capital from process improvements, a risk aversion given process complexity, and finally, the one I mentioned earlier about lack of customer knowledge about the economic benefits of energy efficiency. That was my last slide, and that's all I had. Thanks for listening to me.
Another great presentation. Appreciate the insight, Christopher, and I love the data-driven approach. I took a ton of notes here, and I'm looking forward to having some additional dialogue here as well, and lots of good questions here as well. So last but not least, our final speaker is Taka Kokabu. He is an energy consultant focusing on industrial and commercial energy efficiency projects at VEIC. He implements his technical expertise, which include industrial processes, compressed air, and HVAC to improve process and plant efficiencies. He's interested in behavioral economics and instilling eco-friendly behavioral changes in our homes, workplaces, and communities. Taka, the floor is yours.
All right, thank you. My name is Taka Kokabu. I think everybody could see my slides. Let me know otherwise. But yes, I am an engineer and energy consultant at VEIC. We're a Vermont-based nonprofit organization with offices in Vermont, DC, and Ohio, and I'm in the Vermont office. And this presentation is based off a case study off a project that went on in 2019 and 2020 for one of my Vermont customers. As the turn it off implies, this is kind of just like the industrial version of turn off the lights when you leave the room. I think Peter touched on a little bit of automation in regards to idling loads and how you reduce those, but this will be more on the behavioral side of trying to get operators to do just that, and just the savings are quite surprising. So quick rundown for the presentation. It'll be a case study of the NSK steering systems project. We'll define what idling is through the single machine shutoff project that I did with them first. We'll follow that with the facility-wide shutoff project that we completed, and then we'll round it off by talking about the project savings from that, some ancillary benefits that we discovered during it, and some lessons learned. So a quick overview first. Who are we working with? NSK Steering Systems America. They have an office and plant in Bennington, Vermont, and they are a manufacturer that manufactures steering columns for automobiles. They are a 3-shift operation that's pretty energy intensive, especially in the first shift, at least for Vermont size. And annual electricity use is about 6.5 million kilowatt hours before this project took place. And the key here is that the operators in the plant typically did not turn off the machines when they were not in use. So we were really trying to strike home on that to try to realize some savings. So starting off with the single machine project that took place early in 2019, we were focusing on a single machine that they had called the Rhino 225 press. It is one of NSK's more energy intensive machines there. And UMass did some metering there and auditing to figure out that that machine does idle a good amount, and what if we turned it off during those times? Could we save a good amount of electricity? Efficiency Vermont and myself, we kind of looked at that audit and verified those savings on the metering data, and we came to a conclusion that they would probably be able to save about 23,000 kilowatt hours if they just didn't idle for long periods of time. I'm not saying turn off the machine when it's off, when it's idling for a single minute or two, but during breaks, during lunch breaks, on second and third shift when the machine's not being used, what if you turned off the machine during those times? Because sometimes they were and sometimes they weren't. Those were the savings that were realized. The project closed in May 2019. And so just to really simplify what's going on here, this is the metering data from that project that UMass created. And I drew 2 lines to the right there that are in the dotted blue. One is for when the machine is on. It's kind of averaging about 30.8 kilowatts, and that's productive energy. We're using electricity, but a product is coming out on the other side of the machine, so all is good and well. On the other side, if when the machine is completely turned off, no energy is being used, so all is good there as well, 0 kilowatts. The issue we're trying to tackle here is the idling. In this presses example, we realized that as a third line there kind of indicates, even though the machine was idling, nothing was being produced, it was still using about 66% of the electricity when the machine is on and actually productive. So that's 20.5 kilowatts. That's just, over time, that really adds up to a lot of electric use that is completely wasted. So, that's what we're trying to tackle. And once NSK kind of realized what kind of savings or potential savings there are for a project like this, we got into discussion of, okay, well, where can we go next? What about this line? What about that line? What are the big machines? Eventually, what we were able to get to is that why focus on a single machine or a few lines when we could try to do this on a facility-wide level all at once. So that was great for from NSK's standpoint to be able to jump on board and try that out with us. So the facility-wide shut-off project. The initial step here was to survey all the machines in the facility, 314 of them, and try to figure out what can be and can't be turned off. On the right, as you can see, that's a big Excel file that's very hard to read probably right here, but the green indicates what can be turned off when idling, and the red ones say what can't be. Some of the ones that can't be turned off, NSK might have came to the conclusion just because they were uncomfortable with it. To maybe the ramp up time was too big, so it would interfere with production schedules if they had to turn it on and off consistently. Whatever the reason was, we still got to a point where they said, okay, 86% of these machines can be turned off when idling, which is a pretty significant number. So with that, the project was implemented on July 9th after a month or two of surveying. And then we kind of sat idly, wondering how NSK would do, implementing, putting stickers on the machines, training the operators, trying to, get this behavioral change to take effect among operators. But, as you can guess from New Year's Eve resolutions, like, hey, everybody, let's go to the gym. And that lasts for a week, but then obviously that dies down very quickly, as we all have experienced. So on that same train of thought, these are some project updates from NSK's energy manager through some emails that we received. First was on July 26, 2019. So not too later. As of July 9th, we are fully implemented with the shutoff project. Now it's getting people to listen to me. I have been checking and finger wagging people who don't turn their machines off or e-stop. Hopefully they will get sick of my nagging and start complying. So obviously, the operators aren't really happy with all that, and it kind of takes a little while for people to start listening. 2 months later, they say, okay, shut-off projects is going okay. Still some struggles with getting people to turn off, but worth pulling data, I suppose. See if you made a dent. And so that's what we did. So we looked at some AMI data, some monthly billing data, and kind of graphically showed what's going on. So here is data from 2016 all the way through almost the end of 2019. The years depicting different colors. The dark green is 2018. The dark gray is 2019, and you'll see an orange line come up soon. That'll be 2020. But this is where the project was implemented in July. And a few months later, they said, okay, there might be savings. There might be a dent. Can you look at it? And we look at this and go, okay, between the green and the gray, sure, there might be something, but it's really hard to say. There's a lot of noise, maybe production variances, whatever else. It's hard to say for sure. So we said, okay, let's wait a little longer and see what happens. And as you can see here, So this is a few months later, right up to when COVID started happening. The project savings do start to appear end of 2019. The gap between those 2 years start to widen there, as you can see. And then for the early 2020, the savings become very apparent. 90,000 kilowatt hours for the billing date of January, followed by 135,000 kilowatt hours for February and March. And just to clarify that, it says January there, but that is the billing date. So those savings are typically mostly from December and those holiday times, which I put holiday there. And then moving forward, COVID obviously complicated some things with the shutdown and whatnot. So these are the estimated savings between 2020 and 2019 or 2018 when it became, in regards to the end of that quarter to make sure we're capturing the difference between the shut it off and not. But you could see that the things savings were going great. The COVID times are a little unclear. Followed by July, August, September, when the plant was doing some catch up because of the production losses during COVID times. So I think there were less idling equipment then. And then by the end of Q4 of 2020, they're all kind of caught up with production. And so the savings kind of look very similar to the early part of 2020. Just another way to look at this is some pre-COVID data. But compare 2019 to 2020, a daily average power use, you could see that the line does dip significantly, between the yellow and the orange there, between 2019 and 2020 of the similar time frame. So, and then this is some AMI data, a heat map of it, which is 15-minute interval data on the y-axis, 12 a.m. at the top, all the way down to midnight at the bottom. Left to right is every single day depicted in energy use depicted in pixels. Dark green is very light use, followed by green, then yellow, then orange, and the reds and the dark reds are heavy energy use by the 15-minute interval. So you could see where the weekends are with the green vertical lines when the first shift is 6 a.m. to about maybe 3 p.m. where the red is darkest. Breaks are taken. You could kind of see yellow lines where people might be taking breaks. But regardless, between 2018 and 2019, not too much change here. But what I want to focus here is what happens after the shut it off project. There is the little end there with Q1 of 2020, and all of a sudden you could see all the colors just get very much lighter. The oranges turn to yellows. The dark reds turn to oranges. Even the green sections for the weekends become a little bit more apparent. It becomes very clear that even on a 15-minute interval level, just savings all across the board. 24 hours a day. So what does this mean for savings? On the right, there's a tabular version of some of the savings we saw earlier, but the electricity savings after adding some margin and adjusting for all sorts of variances and whatnot was 1.28 million kilowatt hours for that entire year, or a 22% reduction in electric use in that facility, which is huge. NSK's goal was to reduce electric use by 5% that year. And we were like, how do we get to 5%? And we just blew it out of the water. So obviously peak reductions included there. And at first we were kind of dumbfounded by the numbers, but we looked at the savings and said, okay, well, there were 271 machines being turned off and idle. So on a machine basis, it's only 4,700 kilowatt hours per machine per year. So, okay, the sanity check actually works out. And the important part for customers is that's over $175,000 of utility costs saved per year, which could be used towards all sorts of things. Just to when we're quantify these savings as an energy consultant, there's things we look at. Weather normalization, make sure if one year has a hotter summer and the HVAC's running stronger, make sure those are considered in the calculation. Other effects of the HVAC system, especially with waste heat not being a factor in the facility. Does that then change how the HVAC system acts? Also, production and operational variances. Make sure that NSK, for example, wasn't all of a sudden producing a lot less product, which in this case it wasn't. And also just making sure that if there's other big energy efficiency projects being done at the same time, that we're making sure those are taken out of the savings there. But with that said, some benefits that we saw, other than just we saved money, is one was in compressed air. I think a lot of us know that compressing air is very inefficient. Compressing air turns 88% of electricity into waste heat. So it is a very expensive resource, but is in most industrial places. So a lot of times we do air leak audits and repairs to reduce that, but also idling machines often have compressed air leaking out of them, because the line doesn't know that it's not being productive. So sometimes solenoid valve installations to help shut it off, helps. But as you look on the right, that's data from June 2019 to March 2020. You could just see the dip in the electric use in the compressors at NSK. So, if a company is then looking to replace their compressors in a few years, maybe they'll be able to buy a smaller compressor and scale down the capital cost and whatever else. So, just interesting ways to look at the compressed air system through all this. Another thing is power factor. A lot of times, utilities will penalize for poor power factor. A good example for us is Green Mountain Power in Vermont. Their threshold for power factor was 90%, but they're now trying to increase it to 95%. And so, what if you're sitting the 92% and you're good until Green Mountain Power says you have to increase your power factor, for example. In NSK's example, as you could look to the right, it would not have affected them because their initial power factor was very good, 96 and 97%. But by the time the start-off campaign was running effectively, they ramped it up all the way to 99%. So that was a very nice benefit that we weren't expecting. Maybe we should have, but just we weren't really thinking about it. Ways to improve it is typically installing capacitor banks or replacing old motors. So, if there's a customer that's really looking to improve power factor, just not pay for utility penalties, those are the kind of routes that people usually take. And I think, and those are good ways to do it. But also, other ways are to operating equipment near their rated capacity using VFDs or whatever else. But minimizing the operation of idling equipment could be a very powerful way to get here. So, if someone's thinking about installing a capacitor bank, maybe you could also be like, you could do that, or why not work on the shut it off campaign? Just another way to possibly get to a place where the customer and the utility are both happy. And just a few other benefits: operator and occupant comfort, as well as noise and safety. A lot of waste heat not being put out into the manufacturing space now, especially during summer months where operators is typically hot and have fans on them and trying to ramp up the AC. Just less waste heat in those facilities, I think, could be very helpful, as well as less machinery running is less noise in there. So that's another benefit for the occupants, as well as just safety. Less big moving parts could only attribute to safety protocols, as well as wear and tear on equipment. This is just more hours not being used for the equipment, so maybe you'll be able to extend the longevity of the equipment by 1, 2, or 3 years. So that ends up being less capital projects in the future overall. And then with all the money saved, just being able to just leverage those savings and money into other financial investments, hopefully energy efficient ones for some of it. But I think it gives the manufacturers more sustainability and resiliency, especially in a time when it is more and more needed. So some lessons learned from all this. This is my last slide. But I think, as Peter might have stressed earlier too, having an energy champion and motivated customer is extremely important. We were lucky to have an energy champion on site that was willing to put in the legwork to survey the equipment and do all the tedious work. But that is very critical in a project like this. Metering machines could help push projects forward if the customer is kind of reluctant and says, hey, this is how we do it. Show them the numbers actually work and how much an idling machine does waste. Also, surveying facility machines and processes is critical, as I just mentioned. Just having that organization, figuring out what can and can't be, and getting the okay from management and the operators, and so everybody's on the same page there. And then just to stress that, this is a behavioral change. I think a lot of times we're focused on installing the VFD or changing some controls that are then automated. Or whatever. A lot of times it's just installation of something, but when it comes to human behavior, as we all know, it is something that takes a lot of time and patience. But at some point, you're going to hit a tipping point. NSK actually came back to me a little while ago and said, a while ago it was tough to get people to do something, whereas now, like a operator will be walking by a machine and they notice that someone actually forgot to turn off, and that person will just go over to a random machine and turn it off. At some point, that tipping point will happen where that becomes the baseline. So it's just a matter of time before we could get there. So I think approaching this from an automation standpoint as well as a behavioral standpoint, I think a two-pronged approach, if not more, is very important. And just finally, just questioning current practices. A lot of times, we have examples where we said, well, why don't you turn off this equipment when it's idling, or whatever other practices? Like, why is the compressor set for whatever PSI setting? Whatever it is, a lot of times the answer is usually, well, that's how it's always been, or the previous guy that was here, that's what they told me to do. So trying to actually get at the question and make sure there is a good reason for that, I think goes a long way in possibly making more energy efficient and sustainable practices. So yeah, that's the presentation, and thank you for listening.
Looks like it's time for our Q&A. We've had a lot of great questions show up here. I just wanted to tell you, Taka, I had to chuckle when I heard your words. We save money, and all the other benefits sort of just came out of that. So that's a perfect way to start. I love it. So let me kind of walk through these questions here. There's one from Steve Schultz, I believe, asking you, Peter, what are the big learnings from the virtual experience that you will utilize as the SEM program goes back to the norm, on-site audits and such?
Yeah, it's a great question. And it is something the SEM community is beginning to really talk about. The COVID experience is a shock to an historic service delivery model. And I think it forced the service industry to shift into a virtual mode in an unplanned way. And yet, I think that many of us have seen some benefits. And so I do believe, that it changes the game somewhat. I think what we've learned is that we can be very efficient in interacting with organizations using virtual tools that don't cause them to have to go to the front gate to get you, or us to jump on airplanes and go to factories and expend resources to be able to work together. And so I do think that, and also even if you think about walking around one of these giant car factories, you can only see so much. Whereas if you can drill in through a data system and do some analysis, then get somebody on a call who's operating a system in the powerhouse and talk to them about what you're seeing on the screen together, you can make a lot of progress very efficiently. So I really do think that this is going to cause reverberations in the SEM industry. I know for ourselves, we're very oriented to the one-on-one service delivery model and a lot of virtual relationships. So I do think this is going to change things going forward, and I think that dialogue is beginning to percolate in the industry.
I appreciate that. I should make the correction that was from a question was from Dustin, not Steve. Chris, I'll turn to you next. question here says, were there any technologies or barriers that looked like they may have potential, but you were unable to dig deeply into?
Yeah, a good example of that was for electronics manufacturing. So as people may be aware, in these clean rooms where they produce the electronic chips, they have these air fans that are going pretty much 24/7. And ASHRAE has been doing a study on trying to install VFDs in these systems so you can save a little bit of energy. And in fact, that was one of the measures, one of the 9 measures that we originally were going to explore. But we started talking to vendors, and they said there's so much risk aversion in these electronics facilities that you can show that this VFD is not going to affect their productivity or their product quality. They're going to be skeptical about it. And so, this is not quite a non-starter, but I think it depends on, I know there's different standards for laboratories in terms of airflow. So I think for some laboratories and some electronic manufacturers facilities, you can get away with that. But there's a lot of risk aversion there. So that's a measure where there's a lot of potential, but there's also significant barriers.
Great. Very good. Taka, question for you. Any issues with machines that are not designed for many stop-starts? I know that occurred to me as well. There's certain equipment that A, takes longer to shut down, B, takes longer to start back up, and for which it might be more harmful perhaps to go through the startup shutdown process on a more frequent basis. So any thoughts on that?
Yeah, I agree that could be a possible issue, and I think that is why there were 40 or so machines in this program where the NSK was reluctant to turn them off. But so that was addressed, and they did mention that a good amount of those no's of not shutting it off was due to that, among other reasons.
Good, makes sense. So back to you, Peter. How engaged is top management with those who are managing the actual systems?
Yeah, I think Steve Schultz asking that, John, if I remember correctly, and an experienced question. So, to not sugarcoat it, the challenge of penetrating manufacturing organizations with energy management remains. It's great that the CEOs and folks are, speaking about it, and that's important. But, in plant culture, a plant manager pretty much runs the show and controls local resources. So what we have found is that an ongoing involvement with plant manager to really build that relationship, build the communication is critical. The facilities group, the local management facilities, already definitely adopted energy management in the Stellantis facilities, but paint and other core process areas are really big energy users, but aren't under facilities. Those are under production. So the only way you're going to get at them is if their boss, the plant manager, starts to direct folks to make this priority. So I would say, we're on the journey. We use the management review mechanism in ISO 50001, whether someone's 50001 or not, in all of our SCM participants. That's a periodic check-in with plant manager to talk about what's happening, what's working, what's not working, and debottleneck. This change in North American manufacturing culture is not going to happen just like that. Around energy management, it's a real work in progress. As Taka was describing, it's probably a significant part of the effort, but it is something that can evolve and change, and the top management's critical. And we have found that they are involved. The fact the corporation is putting these transformation costs on them with scrutiny, and energy is a meaningful element. There's a lot of factors that are bringing the plant managers right into the game. And so we are finding, yes, they are involved, but it's an area that still needs to grow.
Yeah, that top-down support in virtually any manufacturing improvement initiative is essential, isn't it? You
Yeah.
can't overrate it. Good.
No.
Good. All right, Chris, back to you. How is market saturation defined in your study? It seems to be based on participation rather than depth of participation. Is that fair? For example, if a site uses one instance of a VFD, they are considered saturated, while they may have additional VFD opportunities still left.
Yeah, it's a great question. And this is something we struggle with this study. So the way we did it essentially is dependent on the measure. So for the one that he mentions, VFDs, we did ask the manufacturer, the manufacturers, how many pumps or motors you have and what percentage of those pumps and motors have a VFD on them. So in that case, it was the saturation in the way I think he's talking about, where what percentage of the opportunities are covered by the technology. However, for other measures like heat recovery, for example, it was more of a binary thing. So either they were doing heat recovery or they weren't. So you could have a food production facility and they're doing heat recovery on their boiler, but they weren't doing it on their canning facility, or they weren't doing it on their compressors. So for those types of measures, retrocommissioning is another example of that. Is either they did it or they didn't do it. In those cases, our estimates of saturation are probably an underestimate of the opportunity. It's like the example I gave you. This food production facility can do heat recovery through other ways besides just the boiler. So those numbers, probably exaggerate the market penetration a little bit. Hopefully that answers the question.
Yeah, I think that's very thoughtful. Appreciate that. Taka, can NSK on-off implementation be feasibly automated to some extent in some way that's sensor-based? Was that considered? And this, I think, is a really important question, right? Can you find some way to remove the human element and through whatever sort of automation, industrial IoT initiative, take the workflows and the data, the real-time data, and other important factors into consideration and actually automate that?
Yeah, a great question. I think for NSK, that wasn't a possibility without some significant capital investment, because they didn't have the controls already installed to be able to run that kind of automation. But I do see that as a possibility in many other facilities where some of those controls are already in place. Was it possible for NSK to do that for a few of their lines? I think yes, but overall it would have been a major hurdle and a big capital expense compared to what happened here, where the capital expense here was buying and printing a few stickers and some time for operator training. So I think automation is definitely possible for some places, but in this case it was being able to do a very low cost way, although time and persistence is also of cost there as well. But so I think it all depends on the facility that you're thinking of. But with that said, I think it's also fully relying on automation, I don't think is the way to go for the future. I think it's very important to make sure that is a part of the conversation, if not a big one. But I think if the operators don't necessarily know what efficient is versus not, and whether it's in our homes or in our workplaces or manufacturing places, get people to understand why we're shutting off equipment or why we're doing this or that. I think the big change of the future, if we're trying to get to our goals of 2030 or 2050, the net zero type stuff, I think we can't fully rely on the technologies. I think we have to rely on the behavioral change to take hold. So, between those two things, we could really get to the net zero that we're looking for.
Yeah, I think that's a great approach. I would say, and you alluded to this, that there are fairly low cost technologies to at least flag someone to say you should consider looking at this part of the process or this equipment, because it looks like it might be a good opportunity to either turn it down or turn it off. But the actual step of turning it off, I think you're right. A human in the loop is probably the best solution, and putting the responsibility and the accountability perhaps for that at the foot of the operator is a good learning and a good opportunity for that kind of activity as well. So appreciate that. Peter, back to you. Given everything going on at the Stellantis site incorporation, how did the utility feel about applying EE funds at this site versus others that needed more help with energy management?
It's a good question. I think Richard Hart threw out there. And so a couple of different answers to that. First of all, we're working with large plants in the territory. And Stellantis is one organization, but there's a number of plants that we're working with. Stellantis is way on the high end of the energy management starting spectrum. But there's many companies working with that are real beginners. And further, the prime contractor, Leidos, is delivering a program of SEM to small and medium industries. So I do believe DTE is essentially, serving the broad spectrum of the industry. I will say, though, that in COVID, one of the things that happened was a lot of the programs kind of froze because, to do residential audits, you have to go to houses. Well, nobody wants somebody showing up to go inside your house in the middle of COVID. Capital project programs really stalled. And so the fact that we were able to generate some sizable energy savings through COVID really was valuable to DTE. So I think, we focused on Stellantis for this case study for the purposes of the ACEEE, but there's a lot more going on there than is represented in that case study. So I think it's a fair question Richard's asking. Is this help being offered to the spectrum of organizations out there? And the answer is yes.
Great. Good. Okay, another question for you, Taka. Is the billing data adjusted for production? Probably an important set of assumptions that go into that, and probably not easy to actually create an apples to apples comparison is my guess, but what are your thoughts there?
Right. I think there like, for example, I work with Darn Tough Sock sometimes in Vermont. And, for them, they have the data to be able to be like, this is more or less, how much electric consumption and how much this or that per sock, for NSK, for example, that wasn't necessarily a realistic metric. Plus and plus one, we didn't really find necessary for, at least for this kind of project. But we definitely did make sure that, year to year, for comparing April 2019 to 20 or whatever those dates are, that there weren't significant, if at all, production variances between the two. So that was definitely something that we verified to make sure these savings were real.
Great. And one more for you, and then I think we're gonna shut down this the specific process and move on to the next one. But Taka, was any work done on translating energy savings to something more meaningful to line operators? I have seen that being effective in other industries.
Okay. Yeah, and I see the question here talking about possible, funds for barbecues, for operators and things like that. Yeah, in an NSK situation in this project, that was not that never came up. I did bring it by as an idea real briefly. It never really stuck, but I think that is a great concept going forward with other customers. I think there was a talk yesterday about gamification. I forget who the gentleman who presented on that was, but I think anyway, when you kind of gamify these energy savings, it would then help people learn what is energy savings, what does shutting this equipment do, like how much are we saving. I think it gets people interested in what is actually happening instead of being like, well, this is what the boss told me to do, so here's the stop button. I think it gets people more involved. So yeah, I've read different stories about other industries and even like colleges and dorms and things like that having, competition between dorms of how much energy you could save. And I think whether you do that in an industrial space, between lines or between buildings or whatever else, I think it could be a very important tool, not just to incentivize and reward the operators and other management, whoever else it is, for what they are doing, but I think it also, I think we learn the most when we're having fun. And if you could gamify and make the working space a little bit more fun or competitive or whatever it might be, I think that kind of helps our society get to a place where, where the behavioral change could actually reach that tipping point on a larger scale. So in NSK situation, that wasn't the case, but I do love that idea, and I would encourage anyone who gets to tackle these kinds of projects to consider that, as will I in the future.
Great. Good. Well, two quick closing comments. Number one, please plan to join us in about 34 minutes at the post-panel debriefs to learn about other discussions you may have missed. You'll have a choice to sort of head into different breakouts and either extend this conversation with this group or engage with other panelists and speakers. So please join us there. I think there's a different login system for that. And last but not least, I want to thank you. In fact, would call for a round of applause if we were face-to-face. Thank Peter, Christopher, and Taka for great presentations and great dialogue. You're clearly experts in your field, real domain experts with a really thoughtful and helpful perspective to share. So thanks for the effort you've gone through to write papers, to go through the submission process, and be here today to share your perspective and your insights. Very much appreciated. So on behalf of ACEEE and the audience here, really, really thankful for your time. So with that, I think we'll close the floor here.
All right. Thanks, Sean. Thanks, everyone.